Welcome back. This is lesson 6 of Machine Learning Zoomcamp session 11. And in this lesson, we will talk about KServe transformers. In the previous lesson, we deployed the clothing classification model with KServe. So we created this YAML file. In this YAML file, we specified the predictor, which points to our model in the saved model format. And we also prepared this test.py file. So this test.py file gets an image, prepares it. So we use here Keras image helper for doing image preparation. And then we send this data to our model that we deployed with KServe. And then finally, we do some post-processing. As we discussed, this is not reasonable to expect from the clients of our model to do that. They just want to send a URL of their image and get back the predictions. They don't need to know what kind of preprocessing they need to apply. They don't need to know that they need to resize the image. They don't need to do any of that. They just need to send an URL and get back the predictions. That's why there is this concept of transformers in KServe. This is very similar to what we did in the previous session. In the previous session, we had this component that we called gateway. This was the component that the client interacted with, and then this component would do all the pre and post processing. In the same way, in KServe, we have transformers, which is doing exactly the same thing. But in case of KServe, this is already a part of these custom resource definitions that we talked about. So this is a part of inference services that we have in KServe, and we can use the same YAML file we have here. So we have predictor here, but we can also add a transformer and then specify the kind of transformation we want to do for this specific inference service. This is what we will do in this lesson. We will create a transformer for our model that will take care of all this pre and post processing. And we already have the code for this pre and post processing. So we will again use Keras image helper that will take care of all that, of downloading the image, resizing, and so on. So mostly we will just use this code. Let us go to KServe GitHub repo. And here we have docs, and let's go to samples. We need to go to v1 beta 1. And here we have this folder with transformers. So this is a documentation for transformers. We have two examples of transformers here. We will need this one, image transformer. Let's take a look what is here. This code here is actually for PyTorch. I think this is a bit old example. The example is still for KServe, not for KServe, but I think we can change that. We can just replace KServe with KServe. So what this thing is doing, it's for deploying a PyTorch model. Let's say we have a PyTorch model that we deployed with KServe, so some classification model. We have users that want to classify some images. And from what I see, they sent a request in the base 64 format. So they get the image. They already download this and they do base 64 encoding. So they sent an image in base 64. And the transformer that we have here, it is getting this encoded version and decodes it, turns it into a pill image, and then applies transformation, this stuff. I think this is something similar to what we do in Keras, this prepare input function probably, and returns this as a list. And then we have this class image transformer with two methods, preprocess and postprocess. In preprocessing, we apply this image transform function to all the rows of our request. Yeah, so we apply this image transform, and this is what we sent. So we sent a transformed image. Then the model does the prediction and then sends something back. And to post-process these results, the output of the model, we use this post-process function, and it doesn't do anything. So it just returns the predictions to the client as is. Yeah, here it just doesn't do anything. Yeah, we do not use PyTorch here, so we don't care much about PyTorch right now. But this is a good example that we can just take and adjust to our needs. So let me copy it. I will create a folder. I will call it, let's say, image transformer. And in this folder, I'll create a file that I will also call image transformer.py. And all this KServe I need to replace with KServe. Actually, I don't need this PyTorch stuff, and I need to replace this with KServe, and the rest I'll keep it like that. Actually, I also don't need this logging and this stuff as well. What I will leave is KServe, and then typing. So typing, this is so-called type hints for Python, which I haven't really used in this course, but these are these things that we have that say that this parameter is string, this parameter is string, this parameter is dictionary, and this thing here says that the output of this function of this method is also a dictionary. So I will keep that. And then what I want to do is I want to take this test.py file and move all the preprocessing logic we have here to this image transformer. So then I'll just take this preprocessor and move it here. Then I will create this preprocessor inside this image transformer class. So it will be a field here. That's why I use self. So self means that this is something that lives inside this object. And then it will be the same preprocessor, basically. And then in this preprocess function, we want to apply this preprocessor to every row of our input. And this is what we did. So let's say every row of our input would be an URL. So actually, I will create a copy of this test. I will call it test transformer. And this will be the code that we will use for testing this transformer. We don't need this Keras image helper anymore. We copied it. And then let me also take that. And I want to show you how our request will look like. So we can take this URL, and then instead of passing the X matrix, our preprocessed image, what we can do is just pass URLs. It can be multiple URLs. So for example, we can just send 2 URLs. In this case, it will be the same URL, can be different URLs. I will just send the same URL 2 times, as if we are sending 2 different URLs with different pictures. And I want to create a method that I will call prepare input, for example. And then since it's a method, the first parameter has to be self. And then the second will be, let's say, URL. Since all these methods have type hints, I will also add a type hint. This is a string. And then the result will be a list. Preprocessed image that we turn into a numpy array, which will later turn into a list, which will later send to our predictor. So we have this URL. We actually need to do self preprocessor to access this thing here, and it returns X. This X here is, I think that is 1 by 299 by 299 by 3, and we only need this thing because here in this case we already have a list of things. So that's why we remove this one here. And here it will be a batch because this is a list, which means I will just do that, x0. I will return the first element of this array, which will give me an array of shape 299 by 299 by 3. Yeah, so here we use this list comprehension. We apply this image transform function to all the elements of this input. I'm not a big fan of list comprehensions because I think these one-liners sometimes can be confusing. So what I will do is I will rewrite it. So let me rewrite it using the usual for loop. So result, this is something that we will return at the end. It will be preprocessed input. And now we just do a for loop, and for each, since our input contains URLs, so I will do a loop over instances. This is what we will send to our transformer. It will have these key instances, and the value will be a list of URLs. So now for each URL in this list of URLs, we want to apply this prepare input thing. So prepare input, and then I will invoke it on this URL, and the output, let's call it row, and then the result and row. So now what we will do here in this piece of code is we apply prepare input to each element of our request. Let me call it request. And then the result will be this thing. And we follow the same convention because this is something that we will later send to our model. And our model expects a request in the same format. So we want to have instances, and then it's a batch of pre-processed images. So now let's talk about this post-process. So in the example, it wasn't doing anything, but we actually need to do some post-processing. So our post-processing is this. So we want to zip the predictions with class names. For that, let me copy classes. And I again will create a field in our class. I'll call it classes. And in this post-process, again, we have, it looks like that. So it's also predictions. So we want to take these predictions and apply this post-processing function to each element of the predictions array. Let me rename this input to response, and then I'll just again have result, and then I will do for prediction in response predictions, and then I apply this thing to each element. I'll call it output, and then result and output. When we return something, we want to follow the same convention. The naming convention will be, we have a key that is called predictions, and the value for this key will be result. Actually, I need to do self classes here. So then it uses this, it refers to this field here. Okay, that is probably the entire transformer. I don't think we need to have any more logic here. When it comes to logic, I think that's all we need. Now we need to somehow run it. In KServe, there is a way of actually running things. This KServe KF model also has some web service functionality. So we can actually run this as if it's similar to a Flask app, even though it doesn't use Flask. I think it uses Tornado or something like that. But we need to start that because this thing here is a separate service. So it will be a separate pod, getting requests from the user, doing something with this request, sending it to predictor, and then getting the response from the predictor, and then sending it back to the user. So this has to be a web service. Let's see how to run it. For that, I will go to code example here. I think this folder actually, so this is this thing here. And this image transformer, this is what we just used. I think it's a little bit more extensive because it has some documentation, some login and all that stuff. It also has this explain method, which we don't need right now, and we will not cover it in this course. So what we are interested in is this main.py file. So this main file is what we execute when we do something like this. So let's take a look at our HTTP server. So we do python -m and http.server. This is actually the name of a module. And then this -m says I want to run main.py from this module. This is how that code that we saw, this is how it is executed. That's why there is this main.py file. In principle, we don't have to do this. We can just execute it in the same way that we are doing that usually. If I go to this image transformer, and then the way we usually execute Python files is like that, just using Python, then the name of the file. So what we can do is we can just do the usual, this main block, if name equals main, then do things here. And now we just need to figure out what exactly we need to do here. So that's why we are in this _main__.py file. We want to see what actually they do here. They do here a bunch of stuff. So we need this argparse. Argparse is a module in Python. I think it's built in, maybe it's not, but this is a module in Python that lets us parse command line arguments. So for example, when we do Python image transformer or something, and then we do model name and then some name, this module knows how to parse these parameters and how to extract this some name and assign it to this model name variable. So argparse is needed for that. What else do we need here? Yeah, so this parser, this is exactly that. This is argparse. Let me put it here as well. Actually, here in this code, it uses KServe. So this is a correct example. It doesn't use the old KF serving. It uses KServe. So we parse the arguments. Yeah, here something complex is happening. So I think it parses a config. I don't think we need that stuff here. What we need is this thing. So this is how we run our KServe server with this transformer. I don't know what this registered models is. Let me remove that. I don't think it's needed. Maybe it's needed for something, but it should work without that. So let me call this thing server and then server start. And these models, it will be our transformer. And then we just need to create this transformer now. It's image transformer. And then we have a bunch of parameters here. We need a model name. Is there an example? Yeah, so this is the example. Let me copy it. So we need to have model name, which is not defined here. I need to define, and then we have this predictor host. I'll call it just host, put it here. And for the model name, in this example, I think the model name comes from this configuration, from config path. Let's just use the same command line interface to pass the model name as well. So let me change it a little bit. And now I will copy this and I will replace predictor host with model name. And help will be the name of the model, and required is true. So it will be a mandatory parameter. Without it, our code will not start. Type it here. So the model name will be args.model name. So this way we configure it, then we create a transformer, and then we start it as a web service. Now let's check if it actually works. So I will do Python image transformer. It complains about no module named KServe. Let me use pipenv to install what I need. Pipenv install. I will need KServe of version 0.70, and then I will need Keras image helper. Probably nothing else. I don't think I need anything else, just these two. Let me install them. Okay, it finished. So now let us do pipenv shell and do Python image transformer. Then we will run it and it will complain about missing arguments. So let us add this missing arguments. That's predictor host, and predictor host for us will be local host 8080. So this is where we send our request to, and then model name will be model name Clothes, I think. So yeah, it's Clothes. That's the name. And since the default port, I think, is 8080, but this port is already occupied by our Istio. So let's use a different one. HTTP port. Let's go with 881. I don't think we need to specify anything else. Yeah, let's run it. So it is working, presumably. So let's test it. We can just run this test transformer. Let's actually modify it a little bit. So I think we already modified it, but we do not print the response yet. So what I want to do is I want to print response without getting JSON first, and then do print response with JSON. So this will be helpful for debugging. We will have some errors right now, and I want to see what is the error code and perhaps also see the content of the response. So let's go with that. And we do not need to do any post-processing because the result we get from the transformer should already be prepared. So we just need to print it as is. We don't need to do anything extra here. So let me now invoke it. The reason for that could be that we send it to port 8080, which is where Istio is listening for requests. And yeah, now all of a sudden, instead of getting the preprocessed array, it gets some strange strings. I think that's what it's telling us. Why there is a string if I expect a number. So we need to change the URL here. This is where our transformer runs. So let me run one more time. And now the error is different. So let's take a look at the logs. So the logs tell us that object of type and the array is not JSON serializable. And I think it's coming from here, from this prepare input, because we tried to return an numpy array here. And remember, we already had this issue multiple times that floats inside the numpy array, they are not serializable. So we need to turn it into usual Python list and usual Python floats, then everything will work. So let's do that, restart it, and try one more time. Now we have another error. Let's see. So now the error is different. It says not found. When we start the image transformer, we say that the host for the predictor is localhost 8080. This is where the transformer sends the pre-processed request to. So it expects something to be running on this address, and something is indeed running. So we have Istio running here, but Istio also expects this host header. And the problem with this transformer, if we go to, I think we need to go to this file and take a look at this. I think the easiest way will be just to go to KServe GitHub repo and then take a look at the code. So we need to go to Python. In Python, there is this KServe package. And in KServe, we have KF model. This is, KF model. This line 59. I'm not sure if anything is there's, so it's not very informative. But what we need to look at is this HTTP predict method. So this is where the error happens. This is how we send a request to our predictor. And these are the headers we set. So the headers are this, and it's just one, and it's content type. So what is happening here is we only send this header. We do not take the header that we sent in our request, and we do not forward it to the predictor. So KServe just drops this header and does not forward it. And that's why when Istio gets a request, here Istio gets a request, but it doesn't have the host header. It doesn't know what to do with this. And it says, okay, sorry, I don't know what to do with this request. And it replies with not found. It cannot find anything without the host header. To fix that, what we can do is instead of connecting our laptop with Istio, what we can do is we can do port forwarding directly to our inference server where we have our clothing model. And then if we do this, if we connect directly with the pod, then the pod doesn't care about the host headers, doesn't care about anything like that. It just gets a request, processes it, and returns the prediction. So what we will do now to work around this issue is just do port forwarding directly to the pod with our predictor. So I'll do kubectl get pod first. So we have our pod with our model, and I'll do kubectl port forward, then the name, and then I will forward port 8080. I think internally it's also 8080. This is TensorFlow serving. I think in TensorFlow serving, the HTTP port is also 8080. And yeah, let's check that. Okay, so there's another error. Let's see if we see anything in logs. So what we see in logs is this value error, circular reference detected. Apparently it happens when we try to process maybe request or response. Let's take a look at the code. I don't see anything wrong here, but yeah, so here I have a mistake. So it should be not result, append result. I think this is the circular dependency. So result contains result. So yeah, of course it should be output. Let me save that and re-execute that. Okay, we finally get predictions. So now we tested transformer locally. So this is our transformer. We can run it locally, we can test it. And the next thing we want to do is we want to add this to our inference servers definition as transformer. I think there should be an example somewhere. So if we look at the documentation of the transformer, then we see that to be able to use it, we need to configure it like that. So let me copy it, and then I will just paste it here. So I didn't copy this part, storage URI. I'm not sure why it's needed. This is probably this is how we configure this particular container, this particular transformer. So we don't need to do that here. Yeah, so this is exactly what we need to specify here. We need to have an image here. So this transformer now lives in a Python file. We need to package this in a container, put this inside Docker. And for that, let me just create a Docker file. And this Docker file will be very similar to what we did many times. Let me open what we did in session 5 deployment. I think we will have a Docker file that we can just copy and use. This will install all the dependencies. Then this one image, copy our image transformer. Since it's just one file, we don't need this entire list. Then let's remove expose, and then entry point will be Python image transformer.py. And remove that, because this is how we run our image transformer now when we were testing it. So in the same way, we can run it in Docker. Now we need to build this image and use it in our YAML. And I can do that here. So I can do it, I can build it. The problem is with KServe, if I just do this locally and I put this name here, KServe will not pick it up. It will not be able to pick a local image. So we actually need to deploy it to ECR or Docker Hub or some remote Docker registry. I, again, already pushed it. There is actually something I did some time ago. If I go to my repositories and look for KServing. So I have this KServing keras transformer, which is a transformer that uses keras image helper. Actually, it is for KServing, which is the old name for KServe. It was created like 10 months ago, but it should still work for KServe as well. Of course, I should probably update it. So if I go to image transformer, this is exactly the same thing that we created here in this lesson, in this video, except it's a little bit more configurable, but the code is very similar. And it is more configurable because you can specify, where's the example? So in the example, you can specify what kind of input your model expects. So let's say if your model expects an input 150 by 150, you can just replace that here. Or if your model is not exception, but VGG or MobileNet, you can replace it here. And if the classes of your model are different, not the same ones as we have here, you can also replace that. So you don't need to rebuild your image every time for every model. You can just take this model and use it for pretty much every classification task that you have. So let me take this one and I will use it here. So I need to remove this one and just leave it like that. So now it will go to a Docker Hub. It will find this image there and it will use this. So as I said, it was created for an older version of KServe, KServing. And we can actually check which version is it. So if I go to Docker file, I can see that this is for 0.201, which is a relatively old version, 10 months old. In KServe, that was like a century ago, but that should still work because it still uses Tornado. It still follows the same naming convention, the same API. So we can just use that. One more thing is we need to add resources. So if we don't specify resources, it might take quite a few resources. So we don't want this transformer taking too many resources. So that's why we can restrict it to, let's say, we can request 1/3 of CPU, and then at max it can use only a half of CPU. And then, yeah, let's say with memory, we can leave it like that. So this is how we define our transformer. Let me stop here. So, and then also deactivate, and let me go to this Lotus folder. And so before I apply, I want to do kubectl get pod, and then we see that we have this clothes predictor model. I see that it has 5 restarts. Maybe actually I didn't give it enough memory. Maybe it needs more. I don't know. Maybe that's the reason it is restarting. Actually, like while we're here, let me quickly check it. kubectl describe what, and then the name. Then I use less, and then let me go to logs. Yeah, so we see that it was terminated because OOM killed OOM is out of memory. So I think it means that, yeah, it didn't have enough memory. So perhaps for request, we need to give it more. Let me just give it more memory so we don't have these problems anymore. For this one, I think that should be sufficient. Okay, so the thing is we have only one pod here, which is the predictor. And now let us apply this YAML config. kubectl apply -f, then our clothes service. So now it is configured, and now we can do get pod again. And we see that we have a new predictor of a new version. So we changed here, we gave it more resources. So that's why it created a version 2 of the predictor. And then we have a version 1 of the transformer. So this is the transformer we just specified here. And actually we can do kubectl logs. And then let's take a look at the logs of this transformer. It's KServe container. And then I'll do less. There's not many logs. So it just says, okay, I registered this model, and then I'm listening on this port, nothing else. So this thing was initializing. Let's check if it's ready. Yeah, it's running. And this thing, because this is running, that's why this one is terminating. And now we can do kubectl get inference services. We see that this is version 2 right now, and the URL is still the same. So we can go to our test transformer and replace it with this 8080. and we again will use Istio. We'll do port forwarding to Istio, not to a pod, and then we will specify the host header, and Istio will forward this request to the right service. Let's test it. Clean it a little bit, then let me test it. Okay, there's another error. Let me check the logs. So we do kubectl get pod. I think the problem probably is here. I think we just saw the logs. Let us take a look again. And we have a problem. Yeah, we see logs. So it's image transformer line 16, and it cannot get this URL. Okay, I think I know what the reason is. So if I go to the code here and open this image transformer and go to line 16, yeah, so here instead of a list of URL, it expects a list of objects. Let me just show you. So instead of this list of URLs here, it expects an object that looks like that. So we have a key URL and then the value of the actual URL, and we need two of them, something like that. So I don't know why I thought this is a better idea than just a list of URLs. I don't think it matters. Maybe it just makes it explicit that, okay, this must be a URL. I saved it. Let me re-execute it. Oh yeah, finally, no more errors. It works, even though it's a bit older version of KServe, it still works. And in principle, actually, all we need to do to make it more up to date is just to replace KServe with KServe, replace all the occurrences. And then in the Docker file, we will need to replace to use a newer version. And that's pretty much it. Okay, so this is how we use transformers for our inference service. Yeah, I must admit that our config becomes bigger and bigger, but the good thing here is that it's still one config, one resource definition where we specify everything. And let's take a look at the plan. So what we wanted to cover is we wanted to see how we can create a service for doing this pre and post processing, this transformer, image transformer that we did. We also tested locally. We run and verify that it works. We found a couple of bugs during these local runs, and that's why these local runs are actually useful, because instead of first publishing your image and redeploying it and then seeing bugs there and fixing, you just test things locally, and sort of the cycle, the feedback loop is a lot faster. So we did this locally, we tested, we fixed all the bugs. We then prepared this file and prepared this Docker image. I would actually push it to Docker Hub, but since I already have a different version, we just went with this. And it's actually a good thing that you saw this transformer, because it's pretty generic and you can use it for any pre-trained, fine-tuned Keras model that is doing classification. So you can just use that. And that's actually it for this video. And in the next video, we'll take everything we did here. We will take this YAML file, this closest service, and we will deploy this to EKS. So for that, actually, we will need to get an EKS cluster and install KServe there. And then after that, we need to do some configuration. And once we finish, we can just take the YAML file we have and just apply it to our Kubernetes cluster there, and it will just work. So this is what we will do next in the next video. See you soon.